Hello, myself Naveen Kumar Saini. In the course of wireless and mobile communication system, today we are going to discuss about the multiplexing and the multiple access techniques. So these techniques are very important in the terms of a wireless communication system. So first of all, we will discuss about the basics of the what is the meaning of the multiplexing and the multiple access, and we will discuss about the what are the use cases of the these two techniques. So first one is the multiplexing technique. So in this multiplexing technique, in the very brief introduction part of that one is, we combine the multiple signals by using the into the one physical channels. So if we want to access the one of the physical channel, and for that physical channel we combine the multiple signals into that. So this technique is up to the at the transmitter side signals. Okay, so we combine all the signals at the transmitter side. So as I just mentioned about the combination of the signal, these signals will come from the different sources. So one physical channel, it can be used for combining all these multiple message signals, all the symbols, and our main target is to reduce the ISI inter-symbol interference. So the examples for this technique which works on, that is the TDM, time division multiplexing, FDM, frequency division multiplexing, code division multiplexing, and the spatial division multiplexing techniques. So now when we talk about the multiple access system, so this multiple access system is for network level concept is there. So in which how the channel can be accessed by the multiple users. So this is defined for the multiple access techniques. So in that the main target is how many users we have which we can accommodate into the network, and how these users can access the channels, given channel. So this is in this phenomena the capacity of the network can be calculated. Okay, so in this multiple access technique, it works on the data link layer of the OSI model. So what are the different examples for multiple access techniques? That is the time division multiple access, that is TDMA, frequency division multiple access, that is FDMA, then CDMA, code division multiple access, OFDMA, orthogonal frequency division multiple access, then SC, that is a single carrier OFDMA system, and then at the last this is the SDMA techniques are there. So these techniques are used for the multiple access, means how to access the channel by the different methods or the different techniques. So in a broad way, if we when we divide this multiplexing and the multiple access techniques, so these are divided, it is based on the, if we divide it on the basis of the bandwidth, then how this bandwidth can be accessed by the users. So these techniques can be divided into two parts. The first one is the narrowband technique, second one is the wideband system technique. In the narrowband system technique, in this system what happens? So in this, the the bandwidth which are used for the channel, that is very narrow. Okay, so narrower than the coherence bandwidth. So this is the one condition for if any bandwidth is called the narrowband bandwidth. So that bandwidth which is lesser than the coherence bandwidth is called the narrowband systems. Okay, so if we talk about the wideband system, so this wideband system, this works on the wide band of the frequency range, so which is greater than the coherence bandwidth. If it is it follows that condition, then we call it as, that system is called the wideband system. So as we categorize the narrowband system and the wideband system, so based on these two categorization, we use a different multiple access techniques or the multiplexing techniques. So in a brief, if we say in multiplexing technique, that is for at the transmitter side, system is take care, and in the case of the multiple access technique, so this is your network level concept are introduced for that. So now if we talk about some categorization of as we have discussed, the first one is the frequency division multiple access. So in this case frequency division, so what happens? So as I said, multiple access technique is to access the one given channel by the different users. So what happened in the case of the frequency division multiple access, in which the one user number 1 will use the one of the frequency out of the given frequency bands. Okay, second user data will be modulated by the second frequency. So suppose this one is the frequency f1, so this is the frequency f2, and in the similar fashion, if we have the user 3, so this user 3 will be accesses the band of the frequency, that is the f3. Similarly, for the if we have the fourth user, so in this case the frequency which is used, that is for f4. Means in the frequency division multiple access, what happen, the band of frequency is divided into the different subcarriers. So these subcarriers are used for the modulation purposes for the different users. So these different users transmit the different signals. Also these signals will be modulated with the different frequencies. So in our example, we are talking about the f1, f2, f3 and the f4. So suppose f3 user is silent. So in this case, the signal which will be combined, that will be from the user 1, user 2 and the user 4. So user 3 is the silent in this case. Okay, so we combine all this and we transmit at the one time instant. So at the one time instant, we combine or transmit the f1, f2, f3 and the f4. So these band of frequency signals are transmitted at the access by the access to this channel, and it is transmitted after the multiplexing of these signals. So what are the advantages of the FDMA system? So one of the very important advantage of this FDMA system is it reduces the bitrate information and use of the efficient numerical codes, which increases the capacity. The ISI will be reduced, but the bitrate will be high in the case when we talk about the FDMA system. So what is the second benefit of that one? So in any of the wireless communication system, the ISI is plays a very major role to reduce the signal strength and the loss of the signal. So this is your ISI. In the case of FDMA system, at the receiver side, there is no requirement of the equalization, because the equalization concept is used to reduce the ISI, to mitigate the ISI, right? Then next is FDMA system that can be easily implemented. It's a very system. This system is not very much complex to implement. The system can be configured so that the improvement in the terms of the speech encoder and bit rate reduction may be easily incorporated. Okay. So next is since the transmission is continuous, less number of bits are required for the synchronization and the framing purposes. So it means that whatever bits we are transmitting from the transmitter, so in the case of the FDMA system, we don't use the more bits only for the synchronization and the framing purposes. It means the whatever bits we are transmitting, that will be used only for the payload. So disadvantage about this FDMA system, it doesn't differ significantly from the analog system, improving the capacity depends on the signal to interference reduction or a signal to noise ratio. So this is one of the issue which occur in the FDMA system. Next is the maximum flow rate per channel is fixed and very small in this case, and the guard bands leads to a waste of the capacity. So as I mentioned in the previous slide about the synchronization and the framing purposes, the different bits are used. So in this case, in the case of FDMA system, when we combine the different band of frequency, so we have to put the band gap between the two frequencies like f1 and f2, so to reduce the ISI. So these guard bands leads to the waste of the capacity as well. Hardware implies narrower band filters which cannot be realized in the VLSI, and therefore increases its cost. So these are the disadvantages of the FDMA system. So when we talk about the time division multiple access technique, so in that case what happened, different users transmit their signals at the different time slots. So we can see in this diagram, in the previous diagram we had the In the case we have this one where we were using the frequencies, but in the case of the time division, what happened, this complete frame of time is divided into the subframes, and subframes will divide into the slots, and each data or the user sources will transmit the signals through the at the different slots. So this is a slot number 1 T1, this is slot number 2 T2, this is the slot number 3 T3, this is slot number 4 T4. So in this way we combine all these time slots and we transmit through the channels, common channels. So advantages for this TDMA system. So FDMA flexible rates. So several slots can be assigned to a user. For example, each time slot interval translates 32 kbps. A user is assigned to 64 kbps slots per frame. So it can withstand rusty or variable bitrate traffic, and number of slots allocated to a user that can change frame by frame. So 2 slots in one frame, 3 slots in frame 2, and 1 slot in frame 3, and so on. So in this way we can do the framing, and we can scalable, we can use the different frames for that. No guard bands are required for the wideband system, and no narrowband filter required for the wideband systems. So these are the advantages for the TDMA system. See, similarly, we have the disadvantages of this. High data rates of the broadband systems require complex equalization. Due to the burst mode, a large number of additional bits are required for synchronization and supervision. Call time is needed in each slot to accommodate time to inaccuracies. Electronics operating at the high bit rates increases energy consumptions. Complex signal processing is required to synchronize within the short slots. Okay, so these are the disadvantages. Similarly, then again next is code division multiple access. What happened into that? In this, the different sources transmit the signals with the help of the different pseudo codes. Like in the FDMA system, we were using D1 into the F1, and in the TDMA system, we were using we transmit the signal at the different time slots. In the case of code division multiple access, we transmit the signals with the different codes. So from source 1, transmit the symbol D1 by using the code C1. Similarly, D2 is the symbol transmitted by the user 2 with the help of the pseudocode. Similarly, D3 and C3 and D4 and C4. So these are all are the transmitted signals by using the different codes. So in this, the code or the pseudocode is C1, C2, C3 and C4. And here D1, D2, D3 and D4, these are the symbols which are transmitted through that. So these are code division multiple access. So if we combine all this in one slide, so we can see in FDMA system we transmit the signals. We first of all we divide this complete frequency band into the small subbands, and each subband will be used to transmit the signals. Okay. Similarly, in the case of the TDMA system, we use the time slots. So these time slots are allocated to the different users. Suppose time slot 1 is there, so it will be transmitted the data 1, and time slot 2 will transmit the data 2, transmit 3 will transmit the data 3, time slot 4 will transmit the data 4, and so on. So when we talk about the one slot, so each slot contains this one, that is data will be the payload of the main informative data which will be transmitted into the slot. Similarly, when we talk about the CDMA system, so in this system we have the different codes, code 1, code 2, code 3 and code and so on. in this we use the same bandwidth for transmitting the data. So each user will be allocated the same given bandwidth, and but different codes, different pseudo codes will be used for that. So just like the code 1 is used for the user 1, code 2 will be used for the user 2, code 3 will be used for the user 3, and so on. Okay. So that is why this FDMA, TDMA, CDMA system we can understand by these figures as well. So when we talk about the CDMA advantages, so in that CDMA has a soft capacity. So it the greater the number of the codes, the more the number of users can be used for you can use these codes for transmission. So it has the following advantages. The CDMA requires a tight power control mechanism as it suffers from the near fall effect. In other words, a user near the base station transmitting with the same power will drown the signal later, and all signals must have the more or less equal power at the receiver. Rack receivers. So these rack receivers can be used to improve the signal reception and delayed versions of time of the signal that can be collected and used to make decisions at the bit level. Okay. So disadvantage, time synchronization is required in the case of CDMA system, as the sum of the power received and transmitted from the base station needs to constant tight power control. This can result in several handovers. Okay. And so in this CDMA systems also is called the reuse factor 1. So now when we talk about this multi-carrier modulation techniques, so in this multi-carrier modulation technique, what is that? The bandwidth channels which cause the inter-symbol interferences. So channel equalization is used for that purpose to reduce the inter-symbol interference, and band pass channel with a specified bandwidth. The information bearing signal may be generated at the baseband and translated in the frequency to the passband of the signal. So alternate approach is to design of a bandwidth efficient communication system in the presence of channel distortion or equivalently ISI. Okay. So what is the mechanism of the multi-carrier modulation? In this, in this case, it divides the available channel bandwidth into a number of equal bandwidth subchannels, where the bandwidth of each channel is sufficiently narrow so that the frequency response characteristics are subchannels are nearly equal. So the basic information about the multi-carrier modulation techniques. So in briefly we can clarify by this diagram. In the multi-carrier, what happens if we have a data stream, that data stream will pass through the serial to parallel converter, and this serial to parallel converter it divides the band of frequencies into the band of frequency to the multiple bands. So how this phenomena occurs? This complete first of all, this data will be converted into a serial to parallel converter by using the serial to parallel converter. The bit M1 bits are there, M2 bits are there, and MK bits are there. Okay. Then each bits will be modulated by the different subcarriers. Like F1 will modulate to M1 bits, F2 will modulate to M2 bits, FK frequency will modulate to the MK bits. And after the modulation, this signal like M1 into F1 and M2 into F2 and MK into FK. So this will be combined at the summer, and this symbol is called the OFDMA symbol. Similarly, another graph is representation for the frequency and time domain F1, F2, F3 and F4. So this time domain for this corresponding is like this one. Okay. So when we combine all this in the frequency domain, we will get this channel OFDMA signal, and when we combine all this, then this distorted signal will be observed at the receiver side. So this is again F1 to F4. These are the different frequencies of the transmission of the signals. So this is a simple representation of the concept of subcarriers, right? So F1, so F4 are the subcarriers of the given band of frequencies. So in the example point of view, we can talk about this like S1, S2, S3, these three are the symbols, and these symbols are modulated by the frequency F1. Symbols F4, S4, S5, S6 are modulated by the frequency F2. S7, S8, S9, these are modulated by the S3, and S10, S11, S12 are modulated by the frequency F4. So the representation for this one is F1 will modulate this symbol, F2 will modulate this symbol, F3 will modulate this symbol, and the F4 will modulate this symbol. After the combining all this is called as the OFDM1 symbol. So when we combine all this as when we combine all these symbols at different frequencies, we call it as the OFDMA symbol. Okay, same representation in the frequency domain is specified here for representing the how this OFDMA symbol can be generated. See, S1, S2, S3 is modulated by the F1, and similarly this is modulated by the F2 and so on. So in the time domain we can represent in this way. Okay, so based on that we will get these modulated signals. So another example for how this OFDMA implement by using the IDFT and the DTFT. So same first block is same, data is transmitted, this data will be divided into the parallel by using the serial to parallel converter. So this will be the M1 as we have mentioned in previous case, M2, M3 and so on, and we apply the IDFT, means we simply do the F1, F2 and Fk if we have the Mk here, right? So this is the combined combination of all this. Then D2A converter, means digital to analog converter is there. Then we transmit into the wireless channel. So after that, at the receiver side, use the A to D converter, and then again we do the DFT. Okay, means we convert it into the time domain. Then again we bifurcate it by using the parallel to serial. So this is the estimated detected data which is at the receiver side, and at the receiver side we use a different threshold mechanism to do the estimation of the signals. So there are some limitations for the multi-carrier modulation, like high peak to average power ratio, that is PAPR. Large signal peaks occur in the transmitted signal when the signals in the end subcarriers adds constructively in phase. Large signals peaks may saturate the power amplifiers at the transmitter and thus cause the intermodulation distortion in the transmitted signal. So these are all the limitations. In then we have the OFDMA, orthogonal frequency division multiple access technique. So how we do this orthogonality? The condition for orthogonality is there must be the null points. So at each null point of 1, just like if you are considering this one, so in this way if we are getting the one null point for this, then for the second frequency, like if this one is the F1 and this one is the F2, so F2 frequency peak must follow the null point of the previous one. Similarly, if we have the F3 here, so for the case of the F3 we will follow the null point of the second. Okay, so we can see this is a null point for this and the peak of this one, null point of this and peak of this one, and so on. So this is the condition for the orthogonality of the orthogonality condition for these 4 sub channels, right? F1, F2, F3 and F4, so and so on. SC-FDMA. So there is a one issue in the OFDMA system, that is the peak to average power ratio. So peak to average power ratio, this issue can be resolved in the case of the SC-FDMA signal. So in this multiple parallel transmissions on subcarriers result in the high PAPR, right? But how to handle this PAPR? By using the SC-FDMA. So that is why this PAPR issue is led in the LT designers to choose the SC-FDMA in the case of uplink direction. So in FC-FDMA, the transmitter adds the M size of FFT at the stage before the OFDMA transmitter, right? So in short, we can say in OFDMA, when in downlink, we use the OFDMA concept, just like in 4G network, like the LTE, and in the uplink, we use the SC OFDMA concept, right? SC FDMA concept in the case of the uplink directions. Okay, so this SC FDMA was chosen since it combines the low PAPR. So this is a very important point into this. To provide the low PAPR, due to the low PAPR, we use the SC FDMA for the uplink directions or single carrier. So this is the simplified block diagram for the SC OFDMA. It's same as the OFDMA, but the difference only is to one block, that is the M point DFT is used at the receiver side, at the transmitter side, and at the receiver side it performs the N point IDFT. So these two blocks differentiate the OFDMA to SC FDMA, right? So this block is for the SC FDMA. If we remove these two blocks, then it will become the OFDMA block. Okay. So I hope you understood about the basic concept about the multiple axis and multiplexing and the multiple axis techniques and their applications in different generations, like 4G networks, as we have mentioned about the FDMA, OFDMA and the SC FDMA system. So these are the references of the from where we have taken these points. Thank you very much.